Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have a sequence an equals n plus 1 over n, and we have to find the limit as n approaches to infinity. And then we have to also state if the sequence converges or diverges. All right? So let's first compute the limit as n approaches to infinity of the sequence, and the expression is n plus 1 over n. Now, notice that this expression can be rewritten in such a way that we can evaluate the limit pretty easily. And since there is a numerator and a denominator, there is always a chance of something going wrong in the denominator. Now, in this case, n is approaching to infinity. So if you just keep the function this way, look, the numerator n plus 1 will be approaching to infinity and the denominator will be approaching to infinity. So it will have the form infinity over infinity. And so we will not know where this function is actually approaching to. But instead of keeping this expression this way, if you just simplify it a little bit, and how to simplify? Look, there is just one term in the denominator. So we can just split it into two different fractions. We can say n is divided by n, and then plus 1 divided by n. So instead of keeping it as one fraction, we split it into two. And then, next step, notice that the first expression here, n over n, is just 1. And then the second one remains as 1 over n. Right? Now, why did we do this? Notice n is approaching to infinity. So the second expression, the second term, where will this approach to? As n goes to infinity, the denominator is getting big, so the whole fraction is getting small, which means this one is approaching to 0. And therefore, this is just limit of 1. And limit of 1 is 1. Doesn't matter where n is approaching to because it's a constant. So this is the limit of the sequence. And since the limit exists, therefore, we also say that the sequence converges. And is converging to 1. So that completes the problem. Thank you.